Have you ever written a few lines of C#, hit run, and just wondered, what is actually happening under the hood? Well, there's this entire invisible world, this kind of protective bubble that brings all your code to life. Today, we're going to pull back the curtain on that bubble, because understanding it, that's the secret to dodging some of the most infuriating bugs you will ever face.
Let's kick things off with a story that I'm sure will feel painfully familiar to a lot of you. 4 hours. 4 hours of your life gone. Not because of a crash, not because of some obvious typo, but because of a silent, baffling failure. This isn't just a tough day at the office. It's the perfect example of why that invisible world underneath your code matters so much.
So we're going to call this the 4-hour bug, and we'll use it as our guide today, because this problem wasn't really about 2 lines of code being swapped. No, it was about accidentally breaking the fundamental rules of the environment where that code was running. And that leads us straight to the big question for this whole explainer. Why is it that a seemingly simple mistake, like getting the order of operations wrong, can make our applications fail in ways that are just impossible to trace? Well, the answer is hiding in plain sight. To solve this mystery, we have to look past the code we write and into the environment where it actually runs. The best way to picture it is to think of the entire .NET framework as a big digital workshop. Now, inside this workshop, you've really got 2 main things. First, there's the class library. Think of this as your giant toolbox, just packed with all sorts of pre-written, ready-to-use code from Microsoft. But the really important part is the engine that powers the whole shop, the space where the work actually happens, and that's the runtime. And it's that workshop, that powerful engine, that we're going to zero in on today. Because if you understand its rules, you can prevent those 4-hour bugs from ever happening in the first place. Okay, so this engine, it has a proper name, the Common Language Runtime, or CLR for short. And honestly, the best way to think about the CLR is as a kind of protective bubble. Now, this is such a critical concept to grasp. Your code doesn't just run wild on the computer's operating system. In the .NET world, it lives and it breathes inside this managed, protected environment. The CLR is that bubble.
So what is this bubble actually doing for us? Well, it's handling 3 huge tasks. First, it manages all the memory, so you don't have to. Second, it's like a security guard, keeping malicious code from wreaking havoc. And third, it abstracts away all the nitty-gritty details of the hardware, letting you focus on what you really care about, your app's logic.
Let's just zoom in on that first point, memory management. The star of the show here is a process called garbage collection. The CLR is constantly, and I mean constantly, monitoring memory, looking for objects that your application is done with. When it finds them, poof, it cleans them up. It's like having an automatic cleanup crew that prevents all that digital clutter that can lead to really serious problems. And this just perfectly illustrates the power of living inside the bubble. With managed code, like C#, the CLR handles all that cleanup for you. But if you jump over to unmanaged languages, say C++, it's all on you. If you forget to clean up your memory, you get a memory leak, which can slow down or even crash your entire application. The CLR literally protects us from a whole class of bugs.
Okay, so the CLR is our protective bubble that manages our application. Got it. But there's another really important piece to this puzzle. The C and L in CLR stand for common language. What does that actually mean for us as developers?
Well, it answers this fundamental question. How can you have one part of your application written in C#, another part in F#, and maybe even some ancient part in VB.NET, and have them all just work together perfectly?
It works because every language that wants to play inside the .NET bubble has to follow 2 crucial sets of rules: the Common Type System, or CTS, and the Common Language Specification, or CLS.
The CTS is basically the universal dictionary for .NET. It defines exactly what an integer is, what a string is, what any data type is. So when you create a variable, that bucket in memory, the CTS makes sure that both C# and VB.NET understand that bucket in the exact same way. There are no misunderstandings.
The CLS, on the other hand, is the rulebook. It lays out the ground rules for good behavior. For instance, C# itself is case-sensitive, right? Console with a capital C is completely different from console with a lowercase c. But to make sure C# can work well with other languages that might not be case-sensitive, the CLS sets a common ground that everyone agrees to. It's all about being a good neighbor in the .NET ecosystem. So here's how it all comes together. You write your code in C#, F#, whatever you want. When you compile it, it doesn't get turned into machine code right away. Nope, it's first translated into a common intermediate language,
Then and only then does the CLR take that common code and execute it. That middle step, that's the secret sauce that makes this whole beautiful system work.
Okay, we've talked about a protective bubble, garbage collection, and a common language. That's a lot. But how does this all circle back to our friend, the 4-hour bug?
Seriously, how does knowing about the CLR actually help us debug faster and ultimately build better software? Let's finally connect all the dots.
Remember the bug? Use authorization was called before use authentication. The issue wasn't a syntax error. The compiler was perfectly happy. It was a logical error that completely violated the rules of the environment. Think of the ASP.NET pipeline, which is built on the CLR, as an assembly line. It expects things to happen in a very specific order. It needs to know who a user is before it can check what they're allowed to do. By flipping the order, the authorization step had no user identity to check against, so it just failed, silently. When you understand the CLR's structured world, you see that assembly line clearly, and you can spot these logical errors almost instantly.
And that, right there, is the crucial point. Understanding these core concepts, the CLR's ordered world, the CTS's universal dictionary, the CLS's rulebook, this is what separates a coder from a true software engineer. It's the difference between just guessing where a bug might be and knowing exactly where to look because you understand the invisible machinery your code is running on.
So we've gone deep inside the .NET bubble today, but the idea behind it, this concept, is so much bigger than just C#.
At its heart, the CLR is a powerful abstraction, a layer that hides immense complexity so that we can be more productive. And when you stop and think about it, our entire digital world is built on these invisible bubbles. The browser's JavaScript engine, the operating system on your phone, the cloud services that run everything, they're all abstractions. So the question to leave you with is, what invisible bubbles are you relying on right now?